Alright, today we're going to explain the FX3U. Using the FX3U-485-BD board, how to do serial communication or achieve MODBUS functionality. This is our requirement. You can see here the FX3U-485-BD board. It needs to be installed in the expansion slot. You can see that it is for pins SDA, SDB, RDA, and RDB. SDB, RDA, and RDB. But actually, for 185 users only to pins. So you need to connect both the pins SDA, RDA together, and both the pins SDB, SDA together. Just connect here and be wire sound. This is how I connected it. I used the DuPont wires to connect SDA and RDA together, and RDB and SDB together. These two wires go out. For the receiving end, it's the same. Today I'm using a computer to receive. I'm using a USB to 420 to 480 fits cable. Connect the two A and B to B. Then connect the two wires. Today, our hardware testing environment ends here. Next, let's talk about the software part. How to do the testing. This is how we installed it. On the other side, connect it to the computer. Okay, now let's move on to the programming part. You can see the program part. It's already written. The upper part is the previous version live program. Next line is M8161, which is you can switch between hexadecimal and octal. The most important is the D8120 parameter, because D8120 includes the communication position, length, quality, and data matching. All settings are here. You can see on the left side of the screen, there should be a diagram. It's the D8120 parameter settings. Next is the station number. Usually, the master is 0. If it's another slave station, there will be a corresponding station number, usually used by the slave end. Next is the RS command. The RS command has the first parameter, indicating the starting position of the data to be sent, the number of positions to be sent. Today we're sending 2. I'm only sending D10 and D11, because when we trigger it, you'll see the M812 status, only sending 2. The received data starts from D500. It starts collecting data. When it finishes collecting data, it will trigger a BIOS telling you it's done collecting. Then you can move it somewhere else and reset it. Then it can collect data again. But you need to understand, when you trigger the RS, it's always in receiving mode. If the M isn't on, it won't receive full send data. Trigger ME with a pulse. Remember, it needs a pulse. After M2, it sends an M8122 pulse. It sends the data in D10, both values. It sends out both values. Alright, let's start our test. Alright, now let's write the data into the FX3U. It's written in now. Let's do a monitoring action. Now the biggest question is, how do I know if it has sent the data? This is the most common question. The answer is the same. Still use MODBUS group, the bottom left position. Set the same communication parameters as the FX3U. Then it will display the sent data on the screen. Set the correct COM port. After opening it, it will start receiving continuously. So, when you want to send data, what should you do? Turn on the RS command. It's in receiving mode. Then it can receive data. The bottom part is blocked. This MODBUS communication software is placed in the bottom left corner. I'll stop it first. If D500 receives data, there will be a value here. Let's do a test. Let's send the data now. Can you see it? Is it changing here? You might not see the value clearly. What's 76769? Let's convert it to hexadecimal. Say 01030000000140i. Is it the same as the sent data? Same as the sent data. So it means the device has returned the data correctly. Now let's see if it can send out. If it completes the sending, if the output is completed, it will receive the data here and display it here. Alright, the method is explained. I'm always in the transmitting and receiving state. M1 when sending. M8122 is a pulse. It sends out the data. Now let's set M. You see it. Combined with all the WN, shows 7400. 7400. Since it's in hexadecimal, it sends both high and low 8 bits of D10. Both high and low 8 bits are sent. Now we can test again, as mentioned before. M8161 is the switch between octal and hexadecimal. Let's turn it on. Send it again. Do you see the difference? 7465. So this is low, both high and low 8 bits. It only sends the low 8 bits. It doesn't send both high and low A bits together. Takes the low A bits of D10, low bar bits of D, and sends them out. That's it. We've completed the RS serial transmission. We can schedule to send and receive once per second, or whatever you need. These are your applications, but you can see if the RS is on and you keep sending data, the communication in the bottom right corner, it will keep receiving. You can check after 0, send it again. Why not now? Because it's full. You need to reset it first, then send it again. Receive 0103. Now it's in 8-bit mode. Each D sends low 8 bits. You can see it. It's like this. Send it again. So it's there. It keeps sending. Because we didn't move it, so it keeps sending. In RS mode, it keeps sending. Turn off the RS command. Now check D500. You see it doesn't receive values when sending. D500 has no value. So the RS command doesn't mean it's always sending when it's on. It's always in receiving mode. Now let's talk about why it receives every time I send. When I send, it always receives. When wiring, a DA and a DB connect to SDA and SDB together. So when you send, you also receive. This is normal. It's a full duplex stage. When using it as half duplex, you'll encounter this stage. When sending, you also receive. Alright, some students use the 428 module as A485. This situation occurs. There are two situations. 485 will filter up the send commands, but if not, you need to combine send data with return data. Combine both. Receive all to get the real length. Alright. This is the RS command explanation. That's all for today. Thank you everyone.